Hey everyone, welcome back. I'm Vishal, and in this final episode of our Solid Principle series, we are talking about dependency inversion principle. It's what makes your code more flexible, testable, and easy to maintain. The principle says high-level modules should not depend on low-level modules. Both should depend on abstraction. In other words, your main business logic should not rely directly on specific classes or concrete implementation detail, but it should depend on the interface or contract. Let's understand this in a simple analogy. Think of your wall socket, right? You can plug in a charger, laptop, or lamp because they all fit the same socket shape. The socket, which is nothing but abstraction or interface, doesn't care about the device or concrete classes. That's how your code should work. Depend on the plug design, not the specific gadget. Let's go to our payment processing system again. See the payment processor class. Not so good version, right? Why? As you can see, payment processor is tightly coupled to credit card payment and calling class directly, which is example of bad design. If tomorrow we want support of any new payment method, PayPal or UPI, we had to add one more line to support PayPal as a payment method. And as the payment method grows, this will get worse. You would have to modify this class, which breaking the open close principles too. Now let's apply the dependency inversion principle and make our system flexible. So to fix this, we can define one generic interface, iPayment method, which will have pay method. Now this interface will act like abstraction or wall socket for payment processing. So instead of calling credit card class directly, we can define iPayment method interface variable in payment processor class. Credit card payment class can implement iPayment method interface like I have shown in code snippet. Now we can call any payment method at runtime without adding new line in payment processor class. While calling payment processor class, I can inject whatever method class object into the payment processor constructor. So to this we say dependency injection. Now each payment type will implement this interface. In future, if suppose I want to support PayPal method into the system, I can easily add this without changing existing payment processor class, simply by defining a new PayPal payment class, which will implement iPayment method interface and can call PayPal method just by passing PayPal class object. And by this, system become more extensible. We can add as many different payment method without breaking existing system and make isolation, which again will help us to debug easily or modify system easily. Now the high level classes, payment processor depends on the abstraction, not on the concrete class. Now in main method, as you can see, I'm injecting PayPal payment into the main method and can call this process payment method directly, right? Sorry, I misspelled it, process, it should be pay method. So process.pay. I can easily call this method without changing my payment processor class where I was earlier using credit card directly. Now it is using iPayment method interface variable. So no dependency on a specific class, easy to switch or inject any new payment method, perfect for unit testing with mock dependencies. This is exactly how dependency injection framework works in .NET, Java, and many modern systems. They inject dependencies through abstraction or by interface, making code modular, testable, and easy to extend. So that's the dependency inversion principle, and with it, we have completed the entire Solid series. I'll create one more video where we will refactor massive payment processing application into clean architecture using Solid principle. Keep in touch. Please like, subscribe, and share this content to your fellow developer as well. I'll come up with more content which will definitely help you to understand the concept, and definitely it will help you to crack interviews as well. So next target is to create a design pattern series as well. So stay tuned. Thank you for watching.